Good evening, everyone, and welcome to the new panel discussion, a forum on maritime industry in the service of the sustainable sea. In an hour and a half, we're going to be talking about green ships. We're going to talk the contribution of shipbuilding for decarbonation of the maritime activities. My name is Mikaa. I'm General Secretary of Sciences Po, and I'll be your moderator for this forum. We have a lot of guests this evening. It's going to be quite dense. A lot of speeches will be short, so don't hesitate to speak slowly to facilitate things for our interpreters. And without further ado, I'll be handing over to the organizer of the panel discussion, Philippe, who is the director of the industrial group of naval shipbuilding.
Bonsoir à tous, merci d'être présents aujourd'hui.
Thank you for coming.
Donc le GICAN, en effet, c'est le
The GICAN is the professional association of the French naval industry and shipbuilding, equipment providers, solution and service providers, design, maintenance, and so forth, both civil and military, and submarines, and renewable marine energy, and systems helping to develop the sea. We're very happy to have you here today. Our area represents 5 billion in turnover manually for France, and 48 billion direct jobs, and 200,000 indirect. I'm going to be very quick because it's quite dense, this particular sequence. I want to get two messages across. First of all, industry is the cornerstone of the nation's power stone. There cannot be a maritime power without there being a strong shipbuilding activity. That's the first point. The second point is that we cannot have a decarbonation process without active participation on the part of industry, and it is the industrials who will be contributing solutions to make it possible to meet those challenges, to have a low-carbon world. Before I conclude, I'd like to thank all of the speakers who are here today and who are online. I'd also like to thank the Minister Delegate to the Industry for her support and her message of opening, which we're about to see on video, I believe. Thank you. I'm very happy to. The interpreter doesn't have the sound. There are key issues for our planet. When you talk about environmental and maritime transport, we think first of all of energy being used to push forward these ships. And the Pact for the Environment is a response to this requirement. So there are several types of wastage that happen during production. So that's why, with respect to work in this area, by industrials of the sea, initiated in the framework of the strategy committee created for this purpose. I get back to two specific actions in France. First of all, the commitment of the area to produce a status report by the end of the year, which could later on lead to a convention for a roadmap for all of the aspects involved. And there are many. The functioning of the sites, as well as manufacturing, the energy used, energy efficiency measures to be implemented, and so forth, and circular economy. All of that can be envisaged so as to succeed in the transition period. That's why for several years, France has been encouraging this type of work with calls for projects from industry notably. Secondly, I would like to draw your attention to the Committee for Orientation of Research and Development of the Industrials of the Sea. So this is a government constructor cooperation, provides a common agenda for R&D. The different areas we're working and the Strategic Committee are involved with shipyards and all manufacturing techniques for ships to reach a green approach, a green yard in this framework. So these actions will have even more impact and success under two conditions. First of all, In addition to the cooperative work undertaken, the coordination with other industries involved will be essential. I'm thinking about energy, I'm thinking about metallurgy, and also about industrial solutions for the future. So that's where we stand now, and I hope that 2022 will lead us forward towards this objective. Now, we need more visibility with respect to these virtuous behaviors so that people can buy solutions that respect this green approach. Now, there is a label, which is a powerful initiative, the Green Marine Label, to support us in this objective. And it's also there will also be, obviously, verification mechanisms to ensure the cleanliness of the label itself. So this is a considerable effort, but this is also an opportunity ecological in nature. So I don't doubt that the exchanges today will be a way of proving that. I'd like to, lastly, to salute the development of sustainable ocean development efforts. There are strong issues involved, and we have to be vigilant about those in terms of acceptability and the programs we want to implement. Necessarily, you will need a dialogue with other teams and based on scientific data. And then we have to talk about biodiversity of the sea, impact studies we'll have to talk about geology, biology, oceanography, and other subjects of interest. So the industrial issues, France is taking a position in these areas, and we're counting on the potential of people working in the sea to produce a very healthy industrial sector, counting on your commitment to cover these activities under the best possible conditions. Thank you for your attention, and wish you a wonderful meeting and a wonderful session of seminars. Thank you, Mrs. Minister, for your words. She's talking about the Green Shipyard label, and we're going to talk about it till the end of our roundtable discussion. But the program is dense, as I said, and we're going to be switching and changing sometimes between French and English speakers. And the next speaker will be an English speaker, is René Berkvens, who is in charge of Sea Europe, who's going to be talking about this. He's going to talk to us in French, René. The floor is yours. Can you hear us, René?
Normalement, oui.
Yes, I can. Thank you very much. And indeed, if you allow me, I will do it in English. I hope I can be. You can all hear me. Let me first of all apologize. I'm not with you today. I am sitting in my study, talking to you from far away. But here I am. My name is René Berkvens. I'm the chair of Sea Europe, and Sea Europe is the European representative office in Brussels of all of the European shipyards and the maritime equipment manufacturers of the EU, Norway, and Turkey. It represents about 128 billion euro business in Europe, and there's about 1 million employees working on it in that particular space. The maritime technology sector is considered to be a strategic sector by the EU. You know, we are involved in if we speak about the oceans, we are involved in defense and security. We are involved in coastal protection, and of course we are generally supporting the economy in terms of the ocean as an energy source, a food source, and of course transport. 90% of goods in the world are being transported by sea, and we are providing the technology and the ships to do that. So that is for a setting sort of where I come from and what I represent. As far as the contribution of the maritime technology to clean oceans, I would like to share with you the following. The first thing that came to my mind on this subject is the terrible accident with the Amoco Cadiz, which is, I guess, more than 40 years ago. in Roche de Port-Salle, which is, I think, maybe only 30, 40 kilometers of where you all are sitting in Brest. A terrible accident, and I think the maritime technology and shipyard industry came a long way to improve those situations. Improve the situation in terms of rules and regulations, which have been changed. New equipment, think about GPS navigation, new propulsion systems, better crews, etc., etc. And more recently, maritime technology companies made an effort to step up and introduce scrubbers to clean exhaust gases, water ballast management systems to clean seawater from invasive species. But of course, the question is this enough? Are we doing enough to clean our oceans? And I guess the answer is no, we are not. We have to step up, and different programs are being launched, of which, of course, the EU Fit for 55 program is enormous, with the objective of zero emission ships by 2050. It's a massive challenge for the industry, but it's also a massive opportunity at the same time. I see where we are today sort of as a historic moment, and sometimes I compare it with the late 19th century when shipping went from sailing ships to steam. And actually today we almost turned back to sailing ships, or at least ships with propulsion coming from other sources than carbon fuels. I am convinced that the maritime technology industry, the shipyards and the equipment manufacturers will meet the technical challenges that are put forward by the Fit for 55 and the 2050 objectives of the EU. We will develop new engines, we will develop new systems that will lead to what we would call clean ships. But the question is, a ship is part of a larger system, and our success, or the success of creating green ships, will very much also depend on others. And to name just a few, I think about the ship owners that have to find their way in a very competitive, world-stretching environment. A very important thing that I believe is very important is the availability of green fuels. We are all thinking that hydrogen is going to solve our problem, but it's not there yet. And on top of that, in the shipping industry, we are looking at different fuels, for instance, ammonia, ethanol, methanol, that all need to be available as a green fuel in the ports where the future ships will be bunkering. And of course, we will need the support from the regulators. Think about the EU, think about the IMO, in terms of the changing rules and regulations. One of them, of course, being the ETS, the EU ETS, which I think is going to play an important role in the change that we are about to make in the next 20 to 30 years. And of course, last but not least, is the public at large, which is to support the change and has to be willing to pay at least part of it. Having said all that, making all these remarks, we as an industry see this as a very important opportunity also to create new business, to create clean business for Europe, and to support our export position. And that's, of course, that is the idea of the Fit for 55 program, to be clean and to create business opportunities. In that sense, we are very much helped also by the EU, where late last year a large co-program partnership research and development program was created between industry and the EU to develop zero-emission waterborne technology and tools. Now, doing the research is one thing. creating the actual product is of course is another thing, and that is the challenge ahead of us in the coming years. But I'm convinced that we will be producing ships that will be able to explore the oceans in a responsible manner, and that will help us to create food, to create green energy, and to become future living spaces on the sea, which think about floating cities and floating ports and other things. I think I haven't looked at precisely the time, but I think this was going to be a short introduction, so I will try to sort of draw a conclusion. The maritime tech sector, as I try to demonstrate, can ensure safe and green ships for use at the sea. There are a few buts that I explained. It's about the fuels, it's about the infrastructure, it's about the entire chain of that makes up the maritime ecosystem that has to support each other to get there. And last but not least, there is a lot of market distortions in certainly the shipbuilding and also the shipping industry that needs to be addressed. There is a clear role for the EU to push out these distortions in the market, and that is something. If we can also do that, I am convinced we can reach the goals that I just outlined to you. Mr. Chairman, thank you very much.
Thank you so much, René. I think we can give a round of applause to René. Of course, it was not an easy thing, an easy task to cover all these things in just 7 minutes. And as a hydrogen market expert myself, I'm really happy that you've mentioned hydrogen, ammonia, and methanol from the get-go. I hope some others will do that too, and maybe the next one will do that. Je vais repasser en français, si vous me le permettez.
I'm going to switch to French to invite the next speaker, Eric Papin. You are Executive Vice President,
vous êtes directeur technique,
Technical Director of Innovation at Naval Group, and you have 7 minutes, sir, to perhaps talk to us about hydrogen. You never know.
Bonjour à toutes et à tous.
Hi, everyone. Indeed, Naval Group. Some of us, you know us, some of you don't. So I'm going to start with a little bit of a summary. We are a worldwide leader in military shipbuilding, and we do systems integrators and architects for submarines and other types of military ships. We have 15,000 staff. We're present in 18 countries, and we have more than 50 Marines, 50 navies that are our customers. So we are committed to environmental production and the reduction in energy requirements, which is manifested in several areas. For several years, we've been supporting the compact dealing with certain energy issues. Also because in the framework of our approach, our CSR approach, we launched this year many areas of work on environmental protection, and reduction of needs, a better knowledge of the expectations of our clients, our military clients, in environmental production and reduction of energy use. Also a commitment in the framework of the coalition for eco-energy transition to propose projects in the framework of the Corner, which could be supported and give rise to some beautiful industrial productions. Lately, we've adopted the guidelines by the Ocean Foundation to measure the impact of industrials such as us, in various dimensions in terms of energy consumption, gas emissions, biodiversity, impact on the sea bottoms. The other thing is that with respect to what we've just seen about shipbuilding, and the shipbuilding of any types of ships, military shipbuilding is a bit specific because the ships we're talking about have very particular missions. And above all, these missions, the military missions and the conditions under which they're executed are actually our priority. So I'm going to focus on a couple of areas where we're different between a tanker and a military ship. We have profiles of use which require very frequent changes of speed. We have detect sectors that require concentrations of energy which are far from a stabilized regime that we have on ships that are just crossing the seas. We also have specific features in submarines. Now, these features in some cases can be positive, in some cases they can be less positive, but what's positive is that for more than 100 years, submarines have been electric. These are precursors of various types of onboard energy. We'd like to make more modern ships, vessels, and to involve a certain new methodologies that can be easily applied in civil applications, such as leak to confined atmospheres, which gives rise to certain constraints. On some vessels, at the top rank, with being nuclear submarines, is very virtuous in terms of covering effluents or pollution, but that's not accessible to all types of the fleet. And military ships can present certain constraints. They have to hold up under shock conditions or collisions. We need to be very cautious about these aspects, and there are also safety imperatives, which are also factors of choice when selecting technologies. So we've made a lot of progress in these areas. I'm going to try to list those during the life cycle of a ship, what the initiatives that we've taken to cover these various times. We've been working on eco-design during the design of our products. What does that mean? Well, it means we try to assess, all things being equal, the weight of the decisions we're making. It doesn't mean we're able to provide solutions for this, first of all, because the requirements of the military, the customer decides, basically. But if we can provide solutions to them, they can select them or not. So what are the examples of these solutions? Well, we've got handling of waste, whether it be solid, liquid, or gas, the possibility of selecting different types of propulsion, electric or mechanical. These are different architectures in terms of hydrodynamics, which will also make it possible in some cases to optimize energy requirements, or at least to some extent. In the design phase, this is also a matter of choice of materials, and increasingly regulations require this to select products that will have the least impact possible. For example, in fighting against corrosion, the selection of paint, of anti-fouling or corrosion materials are very important. We're working increasingly in the framework of respecting MARPOL requirements, having recourse to innovative solution for waste treatment or processing, so we can store waste on board, to process it, and valorize it, and to dispose of liquids that have been made viable. So there's this is all happens in close cooperation with customers. The posture that we have in our area, we're not imposing the offer. In terms of technology, we're responding to needs, and it's important to take that into account. So this is also important to say that in the framework of GICAN, we are undertaking initiatives in terms of the GUIA and the factory plant 4.0. So we are attempting to respect the protection of the environment and the requirements in terms of energy consumption. In actual operation now, for surface-based vessels, they consume almost 80% of the requirements in energy. We're working on innovative solutions for managing energy use. You have to measure something before you can improve something. So we have arrays of sensors to measure what the consumption is in various phases of the life cycle of a ship, and to set up to design algorithms based on cruises and cruising speeds and so forth, so that we can propose to the crew various ways of driving the ship that would be more economical. Based on all of these technologies, this can be integrated into new ships. But above all, we need to recognize that it's possible to do it on ships that are already in service. So all is not lost. We don't have to wait for the next generation of ships to realize savings in energy, which is good news. Now, if we move on to decommissioning ships, here we've made a lot of progress as well to decommission sustainably ships, taking into account all of the recycling processes and various ways of obtaining value from decommissioned articles, and reduce the decommissioned materials, and to help use them in the following ships to be built, and to supervise all of these operations. As information to you, we built a nuclear submarine in Cherbourg, and we're able to reuse more than 90% of the materials that we of the submarine we decommissioned. So what's really important is that we consider now that protection of the environment and reduction of use of energy as a fully featured performance item. So operational performance for combat is number one, but we're making decisions, and when we can make a better choice that's more economical and better for the environment, then we will certainly offer that possibility for the customer, and we'll push them to accept it. Thank you very much. A round of applause, I think, is in order for Mr. Papin for his commitments and his perspectives. Please join me. I won't feel so alone up here. And we're going to match the discussion earlier with a few questions. You certainly understood this now. The imagination of the Green Yard label also applies on issues that is throughout the life cycle of a ship. And we couldn't do that without shippers, or ship owners, and associations who represent these stakeholders. And one of those is Green Marine North America, and we're going to be welcoming him. In fact, he's ill, actually, but he'll be interacting with us remotely by video, and that is David Bolduc, who's the General Manager of Green Marine North America from Canada.
Good afternoon. Sorry for not being able to be with you in person, but I really appreciate this possibility to participate remotely. And I think that at Green Marine, we have an interesting perspective to share on the topic of long-term integrated approach to sustainable shipping. So let me explain briefly what we do. Green Marine is a North American environmental initiative for the marine industry. It was launched in 2007. Our goal is simple. We're trying to make our industry greener. And our tool to do that is the certification program, which recognizes and encourages environmental improvement. So it allows ship owners, ports, terminal operators, and shipyards to benchmark their environmental performance, and it gives them a roadmap for improving further. What makes Green Marine unique is that it's very participative and inclusive. All the certified companies are invited to take part in the design and the revision process of the program requirements, but more importantly, from a credibility point of view, environmental groups, governments, agencies, and scientists also contribute directly. So currently, we have about 160 members or companies in Canada and the United States that are Green Marine certified. What also distinguishes Green Marine is that unlike other green certifications, we target the entire industry, so not just a single sector. So we have a very broad diversity of participants, from very small companies to very big companies, different types of vessels, different types of terminals, and different types of cargoes. So we're not just trying to reward the champions of environmental performance, but the idea is that everybody can and should improve. Initially, we focus mostly on the maritime transportation logistical chain. So that means the ship that brings cargo, which is unloaded by a terminal operator in a port. So those three categories represent 90% of our membership. And this was our vision right from the start. To have a greener supply chain, we need to look at all the components. And I think we could say this is a type of horizontal integration of sustainable shipping. But in the last 2-3 years, we've started to have shipyards joining Green Marine. And this is making us shift our perspective as we're starting to look at the vertical integration of sustainable shipping. This is another way to talk about the life cycle of ships. And I'll get back to it in a minute. But very briefly first, this slide gives you an overview of how our certification process works. So each company or port makes a self-evaluation using indicators with 5 levels. So 1 to 5, and 5 represents excellence and leadership. Then they have to be verified by an external verifier once every 2 years. Results then need to be published, so they are made available publicly. Anybody can see them on our website. So transparency is very fundamental to how Green Marine works. And once you're certified the first time, it doesn't stop there. You have to constantly improve your performance to maintain your certification. The scope of the environmental issues addressed by the Green Marine certification is not exhaustive, but it's pretty broad. We touch on air quality, water and land quality, and even community relations and social acceptability. So some of the performance indicators are only for ships, others are only for the land side, and others are for both. And regarding my previous comment on the life cycle of ships, we launched very recently a performance indicator on ship recycling or ship breaking. So ship owners now have a set of requirements to make sure that at the end of their life, ships are disposed of in the safest and most environmental way possible. What is missing right now, however, in our program, it's a performance indicator targeting the shipbuilding and ship dismantling activities that are very specific to shipyards. For us, it's become a priority to change that. There are 12 shipyards in Canada and the United States that are Green Marine participants right now, and we expect more to join soon. What is really interesting here is that we can make this an international and more coordinated effort thanks to the partnership we initiated in 2020 that led to the creation of Green Marine Europe. So about 3 years ago, the well-known NGO Surfrider Foundation Europe contacted us to explore the possibility of a partnership to create a European green shipping label. We agreed on a license agreement and an adaptation of the program requirements to the European regulations. And this led to the official launch of Green Marine Europe in 2020. This is managed by Surfrider. So this partnership is proving extremely successful. Many ship owners have already obtained the certification or are just about to do so. And I believe there will be an announcement on this topic on Friday. But at the moment, the license agreement is not covering the land side of the Green Marine program. However, since the very beginning of this adventure and partnership with Green Marine Europe, GICAN, the main French shipbuilding association, has been involved in the discussions. And they have expressed their interest in designing specific requirements so that European shipyards can be certified under Green Marine Europe. As we're about to do just that in North America to develop our program more for shipyards, there's a perfect planet alignment to join forces and work together to reduce the environmental impact of shipbuilding as much as possible. We will, of course, welcome the participation of other interested parties in the shipbuilding world. So I think this is a great transatlantic collaboration opportunity that will help make the next generation vessels much greener during their entire life cycle, from cradle to grave. So thank you very much.
Well, thank you, David. Of course, he cannot hear us since he's not with us tonight, but maybe he will watch the replay in some way. So thank you, David. On a évidemment parlé de déjà pas mal de choses.
We've talked about quite a few aspects now. We're going to go even further and look at the design of solutions that are very specialized. I'm going to call to come and talk to us Benjamin Lerondeau from Efinor. You are operating director of Efinor Seacleaner, and that's what you're going to talk about. You have 7 minutes. I'm in charge of the site in Paimpol. We specialize in designing and building depolluting ships. And we're going to go even further now with different partners. You can see them on the screen, Altron, Monta Innovation, to work upstream on the analysis of the life cycle of a depollution ship or depolluting ship. We're going to try and draw conclusions and find an open source software that anyone can use, a designer, a builder, a ship builder, a pleasure boat owner, just to, or builder, to use it in the first design phase to understand the changes that can be brought to the design before the construction to enable them to have a ship that will be more respectful of the environment throughout its life cycle. Now, the targets are to ensure digital continuity between the MBSE, the engineering modeling system, and the life cycle analysis. And the idea is that these two systems are able to communicate with each other and that the blocks assemble so that the designer, the engineer, or the architect can, when they, at the time they need to draw a line or calculate something, can actually check more frequently and more easily to know if the hypothesis emitted or issued during the design phase of the ship is the right one, and if the entry data could not be slightly tweaked or added to with varied elements to draw other conclusions and maybe ensure better and more respectful building, or the ship building of a more respectful ship for the environment. So how do we integrate these two elements? We want to have an open source system so that everyone can use it. This open source software would be called would be the Eclipse Capella one. It would connect the engineering systems and the life cycle analysis software. Now, we in my company specialize in design for shipbuilding. We take part in this project within the context of the life cycle analysis of a building of a ship for an existing project. So we've developed this with Mantra Innovation. You probably know this project. It's a future catamaran to recycle plastics, and we've worked on Modular. It's the smallest module that is going to go closer to the coastline. This Modular is currently in service, and it will be deployed very soon by Mantra Innovation. And the idea is to have a feedback operation of the design and building of this Modular, and also to draw conclusions from it for the next one, the Modular 10, which is slightly bigger, and try to integrate a building block of the life cycle analysis and an environmental design right from the beginning, because having a ship such as this is good, but if you can do this as well as including the full life cycle analysis, that would be even better. As I was saying, we specialized in design and depolluting ships. We had this cleaning ship, and the next step is to have an overall full approach, depolluting, life cycle analysis, and incorporated with the design phase and the actual ship. As on the right-hand side, you have the the visual aspect of the boat. It's an integrated system within the boat or the ship that depollutes everything that's floating, especially and oil slicks and all sorts of things such as this. This is a computer-generated image of the model that exists at the moment. This is the first step. The complex project is ongoing. We don't yet have the conclusions for it. The first step was to extract all of the products on board, a posteriori, of course, the equipment or the machine, the engine, the propeller, the depolluting system, the aluminium parts. There are blow-up parts, there are depolluting bodies, there are floaters, the cables and lights. Extract everything and then see whether it was the right choice, what impact it has on design, what is the impact on the life cycle of the boat, on the cost and on the use. The major building blocks, operational ones, and their limitations are here. Extraction of materials, modelizing, you try to extract data, then the building of the ship, same thing, modelizing or modeling. We try to see which the building blocks of the life cycle analysis that can be extracted from it, then transport, where is the boat going, what's it going to be used for, its usefulness and its maintenance, because we're talking about a boat that needs to be in operation for 25 years. And so these are all steps in the life of the boat that need to be analysed, and we need to try and draw consequences of this right from the beginning, right from the design phase, to be able to offer a ship that is both depolluting and also respects the environment in all its design phases, operation phase and operational phases. And so, as I was saying, the boat, the Mobile 8, is going to be put in operation in Indonesia very soon. The first building block after design and building is transport. We need to bear this in mind. And the approach that comes to mind would be a local approach to avoid having, gas gas or carbon emitting coming out during transport, or emissions of carbon. Then transport, then maintenance, used during collection, transport, navigation phases. We're extracting the data about this at the moment. That's the situation at the moment. And the idea really is to, through this feedback, to offer modular 10. It'll be the big brother version, and if possible with a life cycle analysis right from the beginning of the design phase. That's it. Well, that's great. Thank you very much.
C'était à la fois un petit peu abrupt et pas du tout. N'hésitez pas à nous rejoindre, évidemment, parce qu'on va pouvoir prendre...
Quick and not quick, so please come and join us. We're going to answer a few questions after the last presentation of this forum. We're going to ask Martine Stopford to talk to us. Now, Martine is not with us. Second reason, it's a shame, but we're used to this and have been over the past 2 years. Martine is an economist specializing in the maritime sector, and he's going to talk about blockchain, door-to-door logistics, and the input of technology, which will echo back to what we'll be listening to in the second half part of the roundtable discussion.
Ladies and gentlemen, this is my name's Martin Stopford, and my title for my brief comments this evening are decarbonisation of the maritime trades. And what I'd like to do is start off with a very brief summary of where I've got to in thinking about this, and then follow it up with 3 slides which support the main points that I'm making. So on that basis, if it's okay with you, I'm going to swap to share my screen with you, and you can look at the slides while I give you my comments on the points I'm making. Well, here's the title, and it's, as I mentioned, decarbonisation. The points that I really want to go through, there's actually I've got 6 points here, and the first one concerns propulsion options, because the internal combustion engine, or is it all electric? I mean, these 2 choices are both on the table, and I think it depends really very much what business and trade you're in, which one you go through. I think both are going to run concurrently in variance. I mean, there's going to be many permutations. The more worrying thing, as far as I'm concerned, is the green fuel options. We've got methanol, ammonia, hydrogen, and nuclear seems to be poking its head in right now. They're a very mixed bag. These guys are not really as good as heavy fuel oil in terms of energy density, and they all have some disadvantages, but they will all do the job one way or the other. So you've got to figure out which one to use. And I think my view on the green fuel supply is that this is likely to lag way behind the availability of ships to burn the green fuel. And the reason for this is that the technology can move ahead quite fast to build the ships, but the supply is very limited indeed. And if that's the case, and I'll talk a little bit more about that later, the question is who gets the limited supply of fuel. And when we're talking about a global situation here, and I've got a nasty feeling shipping might not be that high in the pecking order, and this is going to cost a lot of money. So, and the second point, that's the second point really, is it is going to be very expensive to do this. And again, I'll run you through some numbers in a minute. The way I think this will pan out one way or the other, bearing in mind all these factors, is that I think the deep sea shipping will probably go for the internal combustion engines with methanol and ammonia. They're there, they're going to be there fairly quickly. It's well-known technology, and it can cope with long-haul deep sea stuff. The short sea and service vessels, these are much better placed to develop the electric technology, fuel cells, batteries, a bit of hydrogen, that sort of thing, because these vessels well, it's a good platform. It's closer to, it's easier to manage because it's closer to the base, and these vessels operate a lot more in sensitive areas. So I think it all hangs together if you see the development in those areas there. And the final point is that we've got a very big fleet of existing ships, 100,000 ships of one sort or another, and they will, according to my calculations, account for half the emissions in the next 30 years if we go on doing what we're doing. So I think we need to look very hard as we finish off at what happens to these ships. Well, let me now go on to a quick couple of slides, because the first one is the electricity supply, and I'm arguing that this blue line is the electricity supply. It's been growing at 3%. That's the extrapolated trend. Everybody wants it. This is the renewables, solar, wind, biofuels, doing fantastically, but they're still only 13% of the total. And in the last 10 years, they've only accounted for 47% of the increase. So they're not even keeping up with the growth of demand. And if demand continues to grow, and given that these are quite slow to produce, I think we should be thinking in terms of limited supplies. And then that raises the question of how much will it cost and who will get those limited supplies. And on this question of how much will it cost, well, here's I did a little calculation. I thought, well, let's try and figure out, methanol's in the news at the moment with the container ships. So I thought, how would you power a big container ship? This is 23k, burning, I think 200 tons a day, which is 400 tons of methanol, would take, to generate the electricity to synthesize that methanol, would take 36 wind turbines, 10 megawatts each, and that would cost about $1 billion in today's money, as I got good numbers there, and $100,000 a day to run the operation. Well, of course, this is offshore, which is expensive, and solar is looking as though it's going to be cheaper, but still, it's all very expensive compared with a ship like this that today costs $180 million. The second or third point is really that building new ships takes time, and the decisions are not clear-cut. And the reason they're not clear-cut is that we're going to get waves of development. I mean, we've got the advanced diesel ships here in wave 1. We've got the reduced emission ships. These are the sort of hybrids in wave 2. And we've got the green ships in wave 3, all going simultaneously because, of course, the short sea and service vessels are going to start very quickly on the green stuff. And these big ships will go on for quite a while, probably in the deep sea trades. And so you've got a position here where investors are constantly having to decide where to jump in here, and that goes for the shipbuilders and for the equipment manufacturers too. It's all really, I would say, a uniquely difficult situation. And the final thing to say here is just a reminder that the 100,000 ships out on the water today are going to, according to my model analysis, it's not that, probably not that accurate, but it's, it is probably in the ballpark, is they're going to produce 50% of the emissions if we go on doing what we're doing at the moment. So I think the prime target immediately is to deal with these retrofitting and with the management of the use of these ships. They're good for, they're cheap in capital for slow steaming. And I think you put all that lot together and you really come to the bottom line, which is we need to get people who understand this new technology and who can implement these many difficult strategies that we're going to be faced. And that really is the bottom line, I think. People, it's not about autonomous ships, it's about people who know how to make the technology work. Ladies and gentlemen, thank you very much for your attention.
Well, Thank you so much, Martin. That's also some thanks for the replay zone. But anyway, as you've seen, many things we've talked about. Now it's your time to shine, you guys. So feel free to ask. We'll take 2 questions. You can, of course, ask anything to René as well, because I think he's still with us online. So 2 questions or quick comments, des questions courtes ou des courts commentaires.
So quick questions
Des
or
réponses
comments
courtes, naturellement.
and quick answers.
Je vais vous poser la
Please.
question,
And if
rassurez-vous.
there aren't any, I will ask questions because we want the session to be as interactive as possible. No questions, so the interactivity is down to me.
I'm going to do it in English if René can hear us. For the 3 of you, basically, what is the most important part of the life cycle of one ship that must be greened at this point?
Je réponds en français.
Vous pouvez répondre en français, bien sûr.
En français. Non, pour moi, ce qui est important, c'est la phase de conception.
What's important as far as I'm concerned is the design phase. It sets the scene for the rest, and that's why we work a lot on design and innovation with innovative solutions in batteries or fuel cells, for example, or new fuels, because if we miss this design phase, we can catch up later, but far less than if we make the right choices right from the beginning.
Oh, René has frozen. Not sure he's still with us, actually. Okay, so let's move on then to Benjamin. Benjamin, et pour vous alors, est-ce que c'est aussi la conception?
Benjamin, is it the design phase also for you? Yes, and you also need to be able to question this design. When you've done the first life cycle analysis of the first project of the ship, you shouldn't hesitate to go back to the drawing board and think, well, it wasn't the right way of doing it and we need to start again. Eco-design, of course, it goes back to the design regenerative idea that we've been seeing around for 10 years.
You seem to be with us, absolutely. So which part of the ship's life cycle should we green first? Should we green first?
I think you're asking me, Mikaa. The first, I think the gentleman gave the answer there. It's certainly on the design side that you have to make the first steps. Having said that, I would like also to connect to what Dr. Stopford said, which is very much the choice of fuel and the availability of it. I think those are probably the 2 things that will influence right at the start of any building project, of any shipping project, of any shipbuilding project, will influence the most.
Thank you so much, René. So, okay, choice of fuel. That's going to be the second question, quick answer. So which fuel, actually? Full electricity, ammonia, methanol, hydrogen? What's on your mind?
Alors pour les bateaux de guerre, ça sera pas
warships. It won't be full hydrogen or ammonia, or
avec,
it'll be a hybrid system with maybe synthetic fuels added to with batteries and hydrogen, especially for navigation in areas where there's strong restrictions on emissions. But as I explained to you earlier on, the profiles are not necessarily adapted to the types of fuels that we have in the civil building environment. Thank you, Benjamin. What about Benjamin? It depends for the depolluting boat ships on the size of the ships. Smaller ships are fully electric. The reload network is available in all sort of marinas and for smaller units. And for bigger boats, the manta, well, the collected data, no, for smaller ships, sorry, the manta, the collected waste is a source of energy to fuel the ship.
Well, it's in fact, I think Martin Stopford gave the answer. Short distance electric is there. The electric technology is there, and ferries and port-bound vessels are being built electrically. Medium distance, let's say short sea shipping. I think we will see fuel cells in combination with electrical will probably be a viable solution. Long-distance shipping ammonia and methanol. And there we have the enormous challenge that was very nicely brought into one picture by Dr. Stopford. You know, that it is a solution, but you know, just imagine what we need to achieve in order to produce all these green fuels, being ammonia, methanol, ethanol, or whatever. That's going to be a big challenge in the next 30 years.
Sure, that's going to be certainly the challenge of our lifetimes. Thank you so much, gentlemen. You can, of course, give them another round of applause. Merci beaucoup à tous les trois.
Thank you very much to all three of you. Thank you, of course, to our remote speakers. I'm going to call the second people for the second part of this life cycle. We've talked about green energy. We talked about the life cycle of the structure. And we're going to move from upstream to downstream. I'm going to call Claire Joly, who's with us online.
Online, I hope she can hear us. Yeah, there she is. Good evening, Claire.
Absolument.
Ben, merci beaucoup. Thank you so much for being
Bonsoir
here.
à tous.
Et du coup, c'est à vous pendant 7 minutes sur cette question du défi et de l'avenir de l'économie de la mer.
So you have 7 minutes to talk about challenges and the future of the seas. Ladies and gentlemen, good morning. I would like to start in French. I would like to say thank you to the organizers and the GICAN for inviting the OECD. I'm really sorry to not be with you and to benefit from the Breton air, but for many of my colleagues have had COVID and I've been a contact case. I'm going to now move into English.
J'entends la traduction en même temps. J'espère que ça ne vous dérange pas de votre côté.
We can hear you.
She says she can hear the translation at the same time as she's speaking.
Magnifique. The objective of this brief talk is to share with you some recent trends on the ocean economy and highlight the key role of industry players in supporting more sustainable uses of the ocean. So at the OECD, as you can see in this slide, we are developing different pieces of analysis on the future challenges and opportunities facing the ocean economy, with expertise coming from different parts of the house, including shipbuilding, fisheries, the crucial role of development aid and financing, and of course environment, with important work on climate change, plastics, and biodiversity. I head the STI Ocean Economy Group within the OECD, where we analyze the economics, the science, and innovation potentials linked to the ocean. Next slide, please. A few years ago, we launched a foresight exercise looking at the potential of the ocean economy and growing risks faced by the ocean. Here, you see a few sectors where we anticipated much growth in value added before the COVID-19 crisis. You can see tourism, ports, aquaculture, fish processing, and offshore wind. These were some of the top sectors. And this was the first time that all these sectors and many more were assessed all together, studying their interconnection. Next slide. When looking at the situation today, there is definitely further growth in different sectors. So many of our projections are still on track. Business is going very well for many ocean industries. Digitalization, decarbonization, market distortions, growing international competition are affecting entire industries, though, which need adapting. But this exponential growth of ocean economic activities means also that we expect even more environmental externalities. Now, importantly enough, we plan to revisit all these trends and data, the shaping forces for the ocean economy and its sustainability, and launch soon a brand new foresight exercise on the future of the ocean economy to project these new trends and inform policymakers. Next slide. Now, as an illustration of an important sector that we talked about already during the first